Good afternoon, everyone. Welcome to the Composting Collaborative's November webinar. We're going to wait just another minute to allow additional participants to join, and we'll get started shortly. We currently have everyone's phone line muted to ensure good sound quality, but throughout the presentations today, please feel free to ask questions anytime via the chat box in the bottom left-hand corner, and we'll be sure to answer them during the Q&A portion at the end. In case you're wondering, we'll also be sending out the recording and slide deck from today's webinar either later this afternoon or tomorrow morning. The Composting Collaborative was founded about 2 years ago, and our mission is to accelerate composting access and infrastructure to improve soil health and divert compostables from landfill. The Composting Collaborative unites composters, consumer-facing businesses, and policymakers to share best practices and resources, as well as generate innovative solutions to shared challenges. Our monthly webinar series is one way that we aim to highlight best practices and case studies. Since the collaborative kicked off about 2 years ago, we've grown to have more than 80 member companies and over 2,000 subscribers. Some of our members you can see represented here. It's a real mix of generators of compostable material, composters themselves, city, municipal, and state agencies, as well as other important stakeholders. The Composting Collaborative was founded by the U.S. Composting Council, BioCycle Magazine, and Green Blue. We are really excited to be here today to talk about an exciting topic that we've been investigating and researching for some time, pretreatment systems, which is a wide umbrella category of liquefiers, biodigesters, dehydrators, and accelerated composters. I'll be speaking with you today. My name is Charlotte Dreisen, and I'm a project manager at Green Blue, as well as with my colleague James Ewell, our Senior Director of Sustainable Materials. We are excited to announce that not only will we be covering our analysis and findings, as well as a handful of case studies from our research around pretreatment systems, but that the pretreatment directory and guidance document launched this morning online at compostingcollaborative.org. You can go there after the webinar and investigate and explore the resources for yourselves. And as we dive in, it's important to think about kind of what is an on-site pretreatment system. It's a topic that is often a bit opaque for food waste generators, and it's a diverse family of technologies and systems. We tend to group them into two categories for the sake of simplicity and to communicate clearly: biodigesters and liquefiers, or down-the-drain systems, as well as dehydrators and accelerated composters, or dry systems. Biodigesters and liquefiers often aerobically digest food waste using fresh water to dilute solids in combinations with microorganisms or enzymes often, and dehydrators and accelerated composters use heat and a biological process to size reduce and pre-treat food waste to a certain degree. It's certainly a spectrum, and we'll go into the finer nuances of both categories here. Biodigesters and liquefiers use fresh water, as I mentioned, and the aim here is to reduce biochemical oxygen demand in total suspended solids, or BOD and TSS, prior to discharge. Often these systems will have built-in grinders or shredders to help macerate the material, and they can often have little plastic chips in the systems as well to help grind the material down to a more manageable size. These systems release effluent, and they often have to meet municipal sewer discharge requirements. We've seen that a lot of cities and municipalities have strict regulations around what this looks like, and many don't have formal policies at this point about what biodigesters and liquefiers must meet, or have separate permitting or registration requirements, and my colleague James will go into a bit more detail there as well. The aim of biodigesters and liquefiers is to have this initial processing stage that will then go into the sewer system and be transferred to a wastewater treatment facility or a WRF, and ideally be processed by anaerobic digestion further to generate energy, and then be land applied or composted. It's important to understand that, after biodigesting or liquefying food waste, it doesn't necessarily remove landfills from the equation, but it certainly removes trucks from the road in terms of transporting food waste, and it also provides an opportunity for it to generate energy. Some wastewater treatment facilities incinerate or landfill their biosolids. It's only truly recycling if the biosolids that are generated, then go on to future beneficial reuse. It's very similar with dehydrators and accelerated composters as well. Dehydrators use heat or a thermal process to evaporate liquid in the food waste. The effluent is therefore steam that comes out of the systems and the machines. Typically, there are built-in grinders or shredders as well, but not always. They do not use biological processes to reduce pathogens, and this is it's a bit varied. So you can see lots of different specs of what the output looks like and often contrast them with a genuine kind of true mature compost. And depending on the system and how long it is processed, there's a big range. Some process them in 24 hours, some take 3 to 7 days. It will look very different, but it's important that whenever you're using the end output of dehydrators, a dehydrated food waste product, it's important to understand that it is not necessarily the same material or same quality as an end compost that has gone through a full composting process. Therefore, it typically requires additional curing prior to use. It will often be marketed by vendors as a ready-to-use soil amendment or plant fertilizer. Sometimes dehydrators will also market their end product as a compost, but because it typically only uses heat and hasn't had an extended maturation process, it's important to know that it's not equivalent. We also included in-vessel and accelerated composting systems in our research. Typically, a composting drum where food waste is mixed is an amendment with an amendment such as sawdust or wood chips, often in different ratios, but typically maybe about 1-to-1. It can be paired with a pulper or shredder. And accelerated, we use in quotes here because manufacturers state that the units produce ready-to-use compost in 4 to 7 days, though often it requires additional curing phases on site. And we'll look at some really interesting examples of how different institutions have worked to integrate that into their processes and how they use the material at different stages. Comparing dehydrators and biodigesters, or the dry and wet outputs, can be really helpful. Our work was really targeted to help generators of food waste to make more informed decisions about whether these systems are a good fit for them, and if so, what kind. And to a layman, it's often not clear, what the differences may be, what the pros and cons of these systems are, what challenges they may need to be aware of, or where to go for more information. These are a couple rules of thumb that we've found to be true. Most dehydrators can tolerate soiled paper, cardboard, napkins, some compostable packaging. Typically, you'll see that most systems accept anywhere from 5 to 15% of their inputs as kind of paper compostable packaging. It depends on the system. Biodigesters do not have that ability to process the same kind of type of paper and packaging. Biodigesters require significantly higher amounts of water than dehydrators, and conversely, dehydrators use significantly more electricity than biodigesters. And of course, this makes sense when you think through how they work. Biodigesters flushing food waste into the sewer system and liquefying it, turning it into an effluent, whereas dehydrators are using heat, which requires a lot of electricity to size reduce the material. And typically, we've seen that most dehydrators size reduce anywhere from 80 to 90 or so % of the size and volume overall. Most dehydrators are batch systems, whereas most biodigesters are continuous. And while at first this may not seem like a necessarily important distinction, we found in our research that it is in fact a really critical piece of the puzzle for end users. A lot of the institutions using pretreatment systems that we worked with were very acutely aware of when they were generating food waste. So if you have very distinct meal services throughout the day, perhaps a batch system would make sense to you if you knew that it was a very defined period. If you knew you were generating food waste throughout the day at a very regular pace, very consistent pace, maybe a continuous system would make more sense. Biodigesters, we found, are more prone to effluent composition issues related to BOD, basically the amount of organic material that is discharged in the liquid. We did hear of many instances, or some instances, that the effluent of a given system was not within the range of the specs that a vendor may have suggested. And of course, thinking through what is going to be put into the machine certainly relates to what comes out. So that can be a big differentiator as well. One institution that used a biodigester had a huge portion of their waste that was citrus. And it turns out that the enzymes that they were using in their system didn't react well with the extraordinary quantity of acid and citrus that they had in their machine. So that wasn't a technology that they stuck with. So certainly important to think about the type of food waste that you're generating in your institution. Critically, both dehydrators and biodigesters present waste collection savings compared to traditional source-separated organics. A lot of the qualitative information we learned during our research and case studies indicated that kind of the ease and the cleanliness of dehydrators and biodigesters was important to them, in addition to the size reducing. So thinking through what a given grocery might pick up. If you generate 20 64-gallon bins of organics a day, if you can reduce that 90%, that takes up a lot less storage space and certainly a lot less transportation. You can afford fewer pickups. And with biodigesters, when you're directing the material in a liquid form, certainly that's a very parallel benefit as well. Why is now the time to investigate on-site pretreatment systems? With the Composting Collaborative's in-person meetings, we definitely try and assess what important gaps are in the industry and what topics are confusing to both the organics recycling community as well as food waste generators at large. And this appeared to be an area where both composters were curious about how these systems may impact their organics recycling processes. Cities and states were curious, with all of these technologies coming online, how they can help their constituents make informed decisions. And certainly end users or food waste generators were very acutely aware that these technologies could be a benefit, but weren't always certain about to what degree, what they should be aware of, what might work well in their system. So certainly our work, we hope, can work to clarify that with both our directory, which is interactive, as well as our guidance document, which aims to provide context. And James, I'd love to pass it on to you to dive into both of those.
Thanks, Charlotte. Good afternoon, everybody. Thanks for tuning in to learn more about this particular deliverable that we have from an EPA grant that we got from for the collaborative for this past year of work. You'll see when you go to the newly launched collaborative website, we also have some other deliverables from our co-founder BioCycle and the U.S. Composting Council with some compost sampling videos. So I'm going to review quickly what the pretreatment directory looks like and how it functions, and then the kinds of information that we included in the guidance document. One of the first things to note, so these are the vendors that we included in the pretreatment directory. We sent out a survey to a lot of vendors, and with the kinds of data that we wanted, these were the companies that came back with good information. One thing we also learned in the project was that there are many fewer original equipment manufacturers of equipment and a lot of distributors of these technologies that will sometimes call them by different names. So it gives the impression that there are many more technologies out there than there are in reality. So we tried to clarify some of that in the directory. Another thing to note is we ended up, we thought the simplest way to present or organize these technologies was to just classify them as dry output. So that would be dehydrators and accelerated composters, and wet output that would include the biodigesters and the liquefiers. So when you visit the directory, you'll see that you'll have a flat list that's organized by company name and the units that they sell, and there are three ways that you can parse the information to find units that you're interested in investigating. The first one is just whether you think you're interested in a wet or dry system, if you have knowledge or a preference for that. The second is if you have an idea of how much food waste your institution or your business is generating, you can sort units by that volume of food waste. And then finally, a lot of people have an idea of what budget they have available to spend on a system, so you can sort through the information that way if that makes more sense. So inside of the directory, we have what we call vendor profiles. So I'll just show you an example of one wet and one dry so you get an idea of kinds of information it contains and how it's organized. Each profile will have the name of the original equipment manufacturer at the top, and sometimes the equipment manufacturer is the distribution and sales channel for that technology, as is the case with Orca. So you won't see any distributor information, but we try to provide a photo that lets you see what the unit looks like. We'll have a process description for how it works. Then we'll have a section of the directory. Each unit will be listed so you can investigate the capacity, and we'll take a quick look at what that looks like for one of them. And at the bottom of each vendor profile, there are additional information like the length of the product warranty, information like do they offer a service plan, or do you need to go to outside vendors to get that kind of service? Will they rent or lease the units as opposed to selling them? Does the unit process fats, oil, and grease? That's a question that we got a lot from the members. Another set of needs is whether the units will process paper or compostable packaging, and what kinds of items are prohibited from processing, like either damage the unit or just won't be processed by them. You'll see over to the right an image of the unit. We have several case studies that we did based on interviews or site visits because we thought that was a good way to illustrate the utility and the value of how people are using these systems. Sometimes we have additional information, like in this case, there's a nice video that Orca did explaining how their biodigester works, but it's also a pretty good tutorial for how they work in general. If you select on any particular unit, in this case this is Orca's G100, the information that's inside, we tried to keep it simple and hopefully what's the most essential information that people are asking for. So processing capacity, what's the range that the unit can process in a day? If there's any weight limit, that will be noted. The processing time, usually 24, 48 hours in the case of the biodigesters. We'll note price range, volume reduction, what the physical dimensions are for the unit, and also resource consumption, so electricity use or gas use and water use. Charlotte, can you hear me okay?
I can indeed. Thank you.
Okay. I just need to press my headset, I think, to my mouth a little closer. The next example is from a dehydrator, and this you'll see that the original equipment manufacturer is a South Korean manufacturer, and a lot of units, in fact, are made in South Korea. They got an early start on making these pretreatment systems. So in those cases, we will note North American distributors, primary and secondary, and give contact information so people can get in touch with them to ask more detailed questions about their technology. Same format here too. You'll see some of the companies offer many different types of units, so sometimes there can be a lot of information to parse through. Same information here as displayed before, and I'd say, primarily most people will zero in on the price range that they think they have a budget for and how much space they have to accommodate or operate a unit. We'll be sharing some case studies at the end of this, so I won't elaborate on this one, but all of these, if you click on them, they will take you to a PDF where you can learn more about a particular end user's use of that technology. So with respect to the pre-treatment directory, It's a guidance document really, and we created it to accompany the directory because most of the questions that members of the Composting Collaborative were asking about these technologies were not really being addressed directly in manufacturers' marketing information. And good information is out on the web, but it's very scattered, so we wanted to try to bring some of that together in one place. So the guidance document has been designed to provide some basic knowledge about these technologies, defining some terms and descriptions of how they work, similar to what Charlotte presented earlier in her presentation. One of the things that we included is this table comparing selected attributes of interest for both wet and dry systems that we hope will answer some of the questions in a less text-heavy manner. So in addition to the attributes that you see here for volume reduction and odor and pest control, resource consumption, and management of outputs, we've included space requirements, so relative size of units, food waste containers, and the storage area that you need to accommodate handling the materials, the degree of control or assurance for the outputs that can go to building soil or soil fertility, operating cost, convenience, and those kinds of things. We also tried to address the types of questions that prospective purchasers of these systems might want to know. The best technology is really the one that's right for your circumstances or needs. There's not a one-size-fits-all. So your selection of a system will depend on, one, the amount of organics you're generating and the amount of space that you have to accommodate. That'll determine the size of the unit. Obviously, purchase price of the unit. There are also different costs for operating those units that people will need to factor in. On top of that, people have different intended uses for the outputs. So some are interested in just reducing the cost of the materials that they need to landfill. In fact, we found in some states that had organics bans, people were purchasing these systems in order to reduce the volume of material in order to come under those bans, while others are interested in using them to divert materials from the landfill, so they will have them hauled off-site to a composting facility. And then others are interested in actually producing compost for on-site uses. So really, those are the questions that people need to ask themselves when they're evaluating which of these, which type of system and which unit, which particular product is best suited for your needs. There were also several issues that our members raised and that we attempted to answer, but still remain as open questions because we don't really have enough in situ or operational data yet to answer them with a high degree of confidence. So one example or one question is whether dehydrators and accelerated composters actually produce an output that can be classified as compost. So when is compost compost? And there are many vendors that we see making marketing claims that their systems produce compost from anywhere from as little as 24 hours up to 7 days. So in the guidance document, we tried to square those claims with what we know about the science of compost and the length of time it typically takes to create a stable and mature compost product. And in fact, when we asked questions of the vendors about this issue, many of them were willingly offered and tell their customers they recommend for them to post-treat their output for another 3 or 4 weeks or more to produce a more stable compost, or they also recommend that they can mix it in a ratio of between 7 and 10 parts of soil or mature compost if they want to use it immediately. So that was helpful guidance coming from those vendors. Another pressing question from some of our members, especially from city or state water authorities or Department of Environmental Protection staff was what potential impacts down the drain systems might have on aging sewer infrastructure, or even whether newer infrastructure can effectively handle the increased volume of solids. So they also had concerns about the impacts of increased BOD, biological oxygen demand, especially in combined sewer systems during stormwater overflow events, where the concern would be that increased nutrients would go directly to open waters. So we discussed those issues a little bit in the guidance document as well. One example is one of our collaborative members, the New York City's Department of Sanitation. Their approach is to require businesses to register the use of down the drain systems, basically so they can track them, and then they forward that information to the Department of Environmental Protection. And they basically want to monitor the use of these systems over time to better understand their potential impacts to sewer and wastewater treatment systems as compared to the benefits that they offer for managing food waste more sustainably. So it's sort of a wait and see. Other communities who are more reluctant about those systems might be more restrictive in their use and require permits. So that's something that people need to check with their local water authority before they purchase them. We also heard concerns from various environmental NGOs that are in the collaborative, and they were asking questions about what happens to these nutrients after they've been treated in wastewater resource facilities or through anaerobic digestion. And they want to have a better understanding of basically what percent of biosolids or digestate coming from either standalone anaerobic digestion facilities or wastewater treatment facilities that co-digest the food waste. How much of those are actually being compost or land applied as opposed to going to landfill? So we also tried to address that issue and provide information to folks that are asking those kinds of questions in the document. So despite some of the concerns about false marketing claims or greenwashing, or even the fate of the output from these systems, from our research, we walked away believing that these systems offer some real benefits and have the potential to make a positive contribution to our goal of diverting organics from landfills. So just to quickly review those that are on the slide, one, they definitely can significantly reduce or eliminate the volume of materials that people have to manage on site. That is especially useful when you start to consider how they might fit into providing more resilient urban food production zones. If we can keep those nutrients closer to the places where they're being generated and also have them feed urban gardens, that's a pretty exciting prospect for the use of these systems. In general, you can also say that they significantly reduce odor and pest nuisances. So this is a point for dehydrators. So storing organic material that's been dehydrated will help take care of that problem, and that's been a big concern for food restaurants in particular. They want to be good neighbors with other residential areas and others close to them. It's also clear that these systems can result in less hauling of organics, and that has a benefit for reducing carbon emissions and other environmental impacts, such as SOx and NOx from these vehicles. And then lastly, they have the potential to divert a greater percentage of food waste from landfills, and given that landfills are the third largest source of methane emissions, that's a pretty important goal. So we think that they can play a significant role in that. So as I said, when I went through the vendor profiles, you'll see some that include case studies. So Charlotte and I thought it might be interesting to just talk about a couple that we included here. The first one I'll talk about is the Virginia Department of Corrections. And that's an interesting case study because, one, it's the size and scale of operations of the institution. I thought made it interesting to look at how these units can work. And for example, its operations include 27 facilities and 10,000 staff and a prison population of 29,000 offenders. So it's a pretty large institution in and of itself. Its food-related operations involve 24 prison farms that cover more than 16,000 acres, and they also manage 50 greenhouses within those facilities. And I was surprised to find out that they produce 50% of the food that is consumed by the prison population, so both offenders and folks that work in the system. The Department of Corrections performed waste audits and estimated that between 50 and 55% of their waste stream is comprised of food waste. And as you can see from the statistics to the right there that are related to the tons of food waste generated annually and the amount spent to landfill them, VDOC had a great incentive to find a better method for managing this potentially valuable material stream. And their scorecard at the time, they were still landfilling the majority of the materials that were going through the institution and making some strides in recycling more materials, but not composting very much. So their goal was to increase the amount of organics that they could compost. There are some things that make that difficult for this particular institution. One, that high cost is because organics are heavy and therefore they're expensive. They had concerns about holding the organics and composting them on site for rodents and pathogens, and also in rural areas where bears and larger wildlife would be attracted to the piles. But they also had sort of an increased security risk that they wanted to reduce the amount of truck traffic that came in and out of the facility because that is the most common method of people trying to escape from the facility, and it takes a very long time to scan each vehicle and make sure that it's secure before it leaves. So given that, Lois Fagan, the person that's the Virginia Department of Corrections Recycling and Sustainability Manager, she was already managing about 10 composting operations, and her goal was to bring the remaining facilities, I think about 42 of them, into let those have access to composting operations too within the next 5 to 8 years. And some of those facilities were more challenging than others in that those that were high security units, because it's offenders that would manage these operations, they obviously couldn't have them work on those outside the prison grounds. So this led Lois to explore how pretreatment technologies, in this case food dehydrators, could help bring more facilities into VDOC's composting program. So one of the things that they did that was interesting is they ran a couple of trials using dehydrators to better understand the value that they could offer to help increase the amount of food waste they were able to divert from landfills into compost. And you can see from this slide the waste volume and cost reductions were significant. And they went from 5 bags of trash to 1 bag per day, and had a typical conversion ratio of 131 pounds of raw food waste could be brought down to 30 pounds of dehydrated output. and they also looked at how much energy it took and the cost of that energy to run these two EcoVim 250 units for this period of 2 months in the trial. The pretreatment trials also included pilots for the beneficial uses, and 2 examples of that was one, they used output as fish food for a small tilapia farm that was run by inmates, and that food was served in the cafeterias for that particular unit in Wise, Virginia. And the other one was to do some trials looking at the output as soil amendment in several of the greenhouse operations. So they took a rather scientific approach to looking at the value of these units. The other thing, because we're talking about the EcoVim unit, I thought it might be interesting to talk about a study that the Rochester Institute did on Awerco's EcoVim unit. So this is the New York State Pollution Prevention Institute. They performed a comparative assessment between the IVS EcoVim 66 unit, and they compared that to composting, anaerobic digestion, and landfilling in terms of energy use, GHG emissions, and cost. And based on those parameters, the dehydrated food waste was suitable for 5 of the 6 end uses that you see in this table insert that they explored. I thought it was also interesting that they calculated the cost of managing 1 ton of food waste using these units. And in a best case scenario, if the dehydrated food waste were able to be sold for a profit, the cost of processing 1 ton of food waste through an EcoVim 66 could be as low as $11 a ton, which would make it less expensive than composting or AD or landfilling. And in that case, that was for as a fish feed or aquaculture feed, which has a price of $500 a ton. In a worst case scenario, meaning that if you're just landfilling the output, the cost can be as high as $133 a ton, obviously making it more expensive than those other options. So Charlotte, I want to have you go through, I think you're going to do a case study on orca.
Indeed, thanks James. One of the case studies that we're really excited to include in the directory is one about Mandarin Oriental Hotel in DC, which has 2 mid-size orca units. And I believe Shannon Melizon with Orca, who was indispensable in arranging the site visit and providing lots of information, is with us today on the webinar. So thank you, Shannon. Their 2 units, the G50 and G25, were installed about 2 years ago, and they've been overall really thrilled with how the systems have interacted in their processes. It was very important to them to have a turnkey service with installation and maintenance included, and Orca provides one of the most comprehensive on the market, including an every other month checkup and microorganism replenishment, since their system uses microorganisms to help process the food waste as inserted into the machine. It was interesting to hear from the Mandarin Oriental Hotel staff in their decision-making process when they were investigating different pretreatment systems. And many of the staff members that had worked at Mandarin Oriental had worked at establishments prior that source-separated organics to have hauled off-site and composted. And while that certainly can be done in a really sanitary, easy way, they found that it wasn't always up to the par or level that they hoped. So having a system that managed food waste in a really efficient manner that was quick and pretty painless was a primary interest. There are many other hotels in the DC area that use Orca units, including the Four Seasons and Hilton hotels. And the staff here at the Mandarin Oriental feel that they've integrated the units very seamlessly into their processes, with 1 unit in their kitchen and 1 near their catering venue within the hotel. They realized that after a couple hiccups that having to tighten up on their deplating and site checking was really critical. So you can see here on the right-hand side an open unit where someone would scrape food waste off of a plate after rolling it out from a banquet hall or event that they were catering. And with an errant knife or fork entering the machine that you would need to stop and remove it for, they work to integrate extra checks into the process. Here on the left-hand side, you can see some of the signage provided to put adjacent to the machine, which we thought was really stellar. So both Spanish and English labels for what food should and shouldn't go into the system. One of the things that they've been really excited about is how quickly it's processed. And one of the benefits James mentioned in comparing different units was the reduction of odor, and they said that it really overall was very efficient with very little odor, with the exception of, if you have a lot of coffee that you put in it or a lot of one type of material, it may have a little bit of an odor of whatever the predominant item was for a very brief period of time, which contrasts often to how source-separated organics smell, of course, when holstered for a good bit of time. The Orca rotates 3 times per minute with the augers that you can see here on the right-hand side, as well as the biochips, which are about 1 centimeter plastic cylinders. The Orca also sprays microorganisms periodically during this process, and the effluent that's coming out of the machine looks like a chicken broth. And that was one of the things that was really helpful for us in our research to understand, kind of have a better idea of what that looks like. A grease trap is, of course, installed, much like other biodigesters and liquefiers, and one of the things that they work closely with clients to achieve is understand what size grease trap is needed and how frequently they need to be replaced, which is really critical and something that cities and municipalities care a lot about. One of the primary concerns that we heard with New York City, for instance, in talking to their Department of Environmental Protection and Department of Sanitation was that a lot of times end users and clients don't have a real firm idea about how quickly those need to be replaced or changed so that material can flow through without an issue and so that the BOD and TSS levels are kind of within the correct range. So that was something that we were really excited to see kind of paid very granular and nuanced attention to. In addition, something that I'm sure the Orca team can tell you much more about, but we thought was really interesting is the really sophisticated measurement and reporting components of Orca technologies. So if measurement and reporting and keeping on track towards the goal of landfill diversion is important to a specific end institution, a system like this that will measure the amount of food waste, the weight that goes into the machine, and will feed it automatically into a dashboard is something that's really interesting to see, and one can imagine being a really universal benefit to a lot of large institutions. The material here, because the Mandarin Oriental is located in Washington, D.C., goes to the Blue Plains Advanced Wastewater Treatment Plant, and it's helpful to know that they land apply the material, so the food waste does indeed get put to a beneficial reuse. It doesn't get incinerated or landfilled, which of course wouldn't be ideal, since the whole aim of these systems is to make the food waste management process more efficient and circular. It's a really interesting example, I think, of a biodigester being used really well. James, I'd love to turn it back to you to look at another example of a dehydrator.
Okay. Yeah, I guess we've got time. So another interesting example of a company integrating in this case, a dehydrator into its operations is the Sea Pines Resort. It's also a pretty large complex located in Hilton Head, South Carolina. So it's a combination of hotels and restaurants, golf courses, some meeting spaces. The 425 homes on site they do manage them, but they don't manage their organic waste stream. So this case study was just talking about the business facilities. They also did some pretty extensive waste audits in order to see what was flowing through their system to try to get an idea of what the best methods for managing not only organics, but their recyclable waste streams as well. And what I thought was particularly interesting about this is that they sort of had this hierarchy or a three-tiered system for how they managed their organic waste stream. And a portion of it they would steer towards a vermicomposting operation. They estimate about 15 to 20% of it goes there. 20 to 35% would be directed to a dehydrator. And then they would directly compost 45 to 55%, and then finish off that output from the dehydrator in their composting. They had an in-vessel composter. So in terms of beneficial end uses, from the vermicomposting system that they had, they were purchasing worm tea as a fertilizer for their golf greens, and said that it was an excellent fertilizer, but it was expensive. So one of their incentives was to try to create this worm tea in order to, enjoy some savings on using that fertilizer. The units that they were using were Gaia dehydrators, and they had 3 different types. They said that they were using them primarily to process meat scraps and soup and citrus rinds, which I thought was interesting. I don't know if they discovered that those were better processed in the dehydrator as opposed to sending them directly to their in-vessel composter. And then, as I said before, they'll follow up with the output from these units into that in-vessel composter before using the output from the compost on their grounds. So some around the resort and also on the golf courses and some of their banquet halls, I think. They had some advice for some was obvious that metal utensils and large bones. They also, being close to the sea, they serve a lot of seafood, and oyster shells were obviously not good for these units. And while they haven't had any breakages, those kinds of things will jam a unit and cause it. Somebody has to go in and fish it out, which is not a very pleasant task. They did give us one tip, and they said don't mix corn husks with sugar and oil or you'll produce molasses. So we thought that was kind of an interesting, that you can make molasses in a dehydrator. We had not heard of that before. Here are just 2 images of that. It's actually a fairly small and older rotary composter that they were using to finish off the output or compost directly. It's also interesting that this is a very environmentally or sustainably minded company. So what they ended up doing with the oyster shells was bagging them and taking them to the Department of Natural Resources that was conducting oyster bed restoration to help protect the shoreline and create fish habitat and purify the water. This is an area that's been flooded several times now from the hurricane. So that seemed like the best beneficial use for that particular waste stream. I think that's all the information that we have. If we want to go to question and answer, Charlotte.
Perfect. That sounds wonderful. And we have a couple questions related to some of the case studies that you just shared, James. So maybe we can start there. One question is, does Sea Pines Resort process only pre-consumer food trimming? Do you recall?
Yeah, well, they had, there was one banquet hall where they had control over contamination that they would do front of house processing of organics, but all the rest of it is back of house operations. Yep, which is
excellent.
Generates a lot of food waste.
Wonderful. The next question we have is, do composters want to process dehydrated food waste? I know we talked about, how people ought to compost it or cure it further after dehydrating, that ideally, you shouldn't just landfill the dehydrated food waste. But, how do they perceive that on the back end? Is that something of interest to most composters?
Well, we did So in our last in-person composting collaborative meeting, that question came up, and some of the compost manufacturers made some comments, a couple of comments. One is sometimes the material can be too dry and needs to have moisture added to it. And sometimes the material would lack porosity or be too dense, and so they needed to sort of fluff it up. But I think there was consensus in the room that it was a good input. They just needed to figure out recipes for how they mix it. If it is considered to be too dense, so they could get the end product that they wanted.
Thanks, James. Another question, do you have examples of aerobic digesters, and for those who may have tuned in late, either biodigesters or liquefiers, which do not produce gray water but rather come out as a solid similar to a dehydrator?
No, I don't. I mean, one technology that we wanted to put in the directory, but the manufacturer didn't get the data to us in time, and hopefully we'll keep adding to this directory if vendors, manufacturers are interested in having their technologies represented. But folks have probably heard of the grind to energy system, where rather than the slurry going down the drain into wastewater facility, it goes to a holding tank and then is picked up on a regular schedule and taken to either to a co-digestion facility at a wastewater resource facility or a standalone digester. And we did hear there were examples of where people were separating solids from the output from a biodigester and trying to use the liquid fraction as gray water, but I don't think we had an example where there was a solid produced. Do you remember anything about that, Charlotte, from talking to people?
No, I don't think so either. Maybe on that note of kind of the output of biodigesters and their effluent and where it goes, can you talk a little bit about and elaborate more on land application from wastewater treatment plants and the challenges or benefits of doing that?
Sure. So as I understand it, there are two different classifications for land-applied biosolids, Class A and Class B. And if Nora is, well, I guess we can't have anybody pipe in on the audio, but she or Ned have a lot more expertise on this. But it's a matter of how much a wastewater facility will treat those biosolids will determine where they can put them on agricultural land. So obviously they have to decontaminate it to a certain extent and stabilize it before it can be land applied. But that's one definition. In terms of beneficial uses, at least the environmental NGO community, I think they recognize that that's a beneficial use, that it's going back to soil. But many would prefer to see, composting, to have biosolids and digestate folded in as an input into compost manufacturing operations. I don't know if that answers the person's question.
Yeah, I think so. Thank you. We have a couple questions about the relationship between accelerated composters and dehydrators. If we might be able to revisit and kind of clarify how we define them and how they're related and how they might be different.
Yeah, that's a great question, and one that we sort of struggled with. So just in terms of how they work, an accelerated composter, most of them they used to be sort of large vessel systems, and then in recent years they have started to reduce the footprint of those to make them more accessible to a greater number of users. So they'll be big, what I call drum style units that require very little energy to turn on an axis, and material is fed in and rotated like a tumbler over time and simulates kind of the natural microbial activity that you will find in a composting system. as opposed to a dehydrator that are batch units and use electricity and heat basically to evaporate the water from the organics, and it's a high enough heat that it kills pathogens and stabilizes that material. So it's ready to then be mixed with soil or compost, or you can haul it to a composting operation where it can be further treated, to make it mature compost.
Thanks for going into those nuances. We have a question about what kind of testing is needed for the end product for dehydrators or accelerated composters. What would you recommend for someone who wants to have a better idea of what the output really would contribute to soil?
Well, we were also asking that question. In fact, we asked vendors if they had certificates of analysis for the output, so we could see what were the measures of stability and pathogen reduction and sort of nutrient levels. And some of the vendors had those. If you're considering buying one of the units, you should ask them to share those with you and have a discussion. We think the USCC's seal of testing assurance, those testing parameters are a good thing to require. But there aren't, one of the things that we talk about in the guidance document is there aren't any very concrete demarcations for when something has arrived at cured compost. There are the amount of time, compost manufacturers are being pressured to reduce the amount of time that it takes to produce output, as little as 60 days in some operations or 90 days. But when we asked people more knowledgeable than us about how long it takes to procure good, high-quality compost, we would get quotes anywhere from 90 to 180 days. So this is where when you can call something compost. That's why I had that slide. When is compost really compost? That's a question that we hope will be explored more, and people can get a better idea of these units. And if they sort of accelerate the process in general, so it can be finished off, it seems like it's reducing the overall time that it takes in order to have a usable output and a good feed stream for composters. That was our conclusion.
Really helpful. Thanks, James. I'm going to pause just for a brief update from our partner, Carrie Oceans, with the U.S. Composting Council, who mentioned that the U.S. Composting Council will be producing a directory of in-vessel composting systems that would be suitable for institutional situations early next year. Just as a note, since I'm sure a lot of this audience will also be interested in that as well. James, I know that we touched on this in the beginning, but if you'd be able to touch on how people can find the pretreatment directory, whether case studies are included, and how they can reach out for more questions.
Good question. So you can go then, Charlotte, off the top of your head, what is the URL for the directory?
It is compostingcollaborative.org, and it's accessible by, if you click on Work on the top right corner, you'll be able to select the pretreatment directory. Yeah,
and I think that we've even got, if you hover over that, you can click directly on the pretreatment directory. It's also going to be cross-referenced in the resources section. And as we said earlier, so other deliverables for the collaborative from this EPA grant were BioCycle produced 2 reports that you should look at for the data from the states about collection of organics and processing, and also 2 videos from the USCC on how to properly sample a compost pile in order to get good measurements for And I don't know if it's related to the STA or not. Do you know, Charlotte? If it's preparing a sample for that testing?
Yes, I think that it certainly would be relevant for that process.
Yeah, maybe Carrie will answer that via the chat.
Excellent. Well, I know we are just about at 4 p.m., and I think that most of our questions have been answered. So it would be great to share with you all who are on the line that our December webinar will be on Tuesday from 1 to 2:30 p.m. Eastern. Carrie Oceans with U.S. Composting Council will be moderating this discussion with Rhodes Yepsen with BPI, Ned Beecher with NEBRA, Jeff Cooter with AgriSource, and Rooney Kim Lazcano with Purdue University. And the discussion will be centered around PFAS, or perfluorinated chemicals in compost, which is, of course, something that we've dealt with, the Sustainable Packaging Coalition, for some time as a grease and moisture-resistant barrier that can certainly make its way into a composting pile from a variety of sources. And they'll be investigating why that is important and a primer on the most important considerations that a composter should be taking into account around perfluorinated chemicals. In addition, we'd like to share that all participants here are welcome to join the Composting Collaborative. Membership is free, and members of the Composting Collaborative are asked to stay in the loop, plug in, and engage with our growing community. All stakeholders in the composting supply chain are encouraged to join, and you can find the membership application on compostingcollaborative.org. In addition to that, as we mentioned, our new site has just launched today, so we encourage you all to please feel free and explore it. Head to the pretreatment directory from the work page and let us know what you think. We're eager to have feedback and suggestions for improvement. If you know of any really great case studies of institutions using pretreatment systems, we'd be thrilled to hear about them and to include them as we grow our robust library of case studies. And in addition, once you tune off and head out of this webinar, please do leave us feedback. We're always looking to improve our monthly webinar series and would be really grateful for any thoughts or comments in that regard. And a last note that we will indeed be sending on the slides and recording of today's webinar later on today or early tomorrow.
And Charlotte, I didn't know if you wanted to tell them that they can find, there will be an archive of all the webinars that are done through the Composting Collaborative on the new website.
Yes. How could I forget? That's what I'm most excited about. You will now be able to find all of our monthly webinars recorded and archived under the resources section of the Composting Collaborative website, which we hope will be an opportunity to plug in and tune into ones that you missed or be able to go back and refer to them on an ongoing basis. So that's something we're really excited to be able to provide in our new website. Thanks, James, for reminding me there. Wonderful. Well, with that, I think we'll tune off for now and plan to circle back on Tuesday the 18th for the December Composting Collaborative webinar. Thanks so much all for tuning in.
Right. Bye, everybody.